Hello everyone, let's explore the new challenging intro problem from a Math Olympiad Contest. Question is, calculate the integral from 0 to pi over 4 of x squared times sine 2x minus cosine 2x over 1 plus sine 2x times cosine square of x dx. Okay, so before let's review some concept. Okay. Alright, so the first one is going to be double angle formula. Sine 2x equal to sine x cosine x. Now cosine 2x equal cosine square of x minus sine square of x and equal. If I replace sine square of x with 1 minus cosine square of x, and I get this formula. And similar, if I replace cosine square of x with 1 minus sine square of x, I get this formula. Okay. Next one, 1 plus sine 2x. Okay, 1 plus sine 2x. All right, 1 which means sine square plus cosine square, right? All right, and sine 2x is come from here, this formula right here. All right, so plus 2 sine x cosine x. And this is actually complete square, so it's going to be equal to sine plus cosine square. Okay, now 1 plus tangent square of x equal 1 over cosine square of x. This is because tangent square equals sine square divided by cosine square, and you just simplify. Now derivative of tangent s equal 1 over cosine square of x. Next one, derivative of this one. Okay, so I need to prove this formula. So I need to take derivative of tangent square of s plus 1 over tangent of s plus 1. Okay, so I need to take the derivative of this one. So basically I have the chain rule. So u over v integral u over v derivative equal u prime, right? V minus v prime u over v square, right? So this is the general derivative, right? Now I need to apply this guy into this formula, right? So basically I have tangent u which means tan square of s plus 1. So derivative of this one equal to and then you have this, right? Use alpha integral derivative of use power alpha, so equal alpha u alpha minus 1 times u prime. Okay, so u in this situation we mean tangent x, right? So I have 2 tangent s times, right? Times what? Tangent s derivative equal 1 over cosine square of s. Okay, so I put cosine square of s right here. All right, and then derivative of 1 should be 0. Okay, right? This guy multiplied by tangent s plus 1. Okay, right? Minus, right? Denominator derivative of this one should be tangent of s should be 1 over cosine square of s. Okay, and derivative of 1 should be 0, right? And then multiply by the top, right? Multiply by tangent square of s plus 1. Okay, over tangent of s plus 1 altogether square. Okay, now I need to simplify this one. So basically I have 1 cosine square, 1 over cosine square of s. This is this guy and this guy. This is the common factor, right? So I just factor this one out. Right, so basically I just factor this one out and I put cosine square of s on the denominator. Okay, so basically I have what, and I distribute this guy to this. Okay, to this. Okay, so I have 2 tangent square of s plus 2 tangent s. Okay, now this guy I distribute -1 right here over here. So I have what? Minus tangent square of s minus 1. Okay, over I bring cosine square of s to the denominator. So it should be cosine square of s times tangent s plus 1 square, right? Okay. So now I just simplify. So 2 tangent square of s, tangent square of s could be tangent square of s. Okay, and then plus 2 tangent of s, right? And minus 1, and over cosine square of s times tangent s plus 1, right? All right, so this is exactly right here. Okay. All right, next one, I need to take derivative of this one. Okay, so I need to erase this one. Okay, so I need to prove this one. So derivative of natural log of tangent s plus 1. All right, derivative of this guy. All right, so we have natural log of u, derivative of this one. All right, equal u prime over u. All right, so basically u prime. Okay, so u equal tangent s plus 1. Okay, so tangent s plus 1 over tangent s plus 1. This guy should be derivative. Okay, now derivative of this one, tangent s should be 1 over cosine, right? So 1 over cosine s, right? Cosine square of s, and the derivative of 1 should be 0. Okay, over tangent s plus 1. Okay, now I bring cosine square of s to the denominator, so it should be 1 over cosine square of s times tangent s plus 1. Okay, I don't have enough space, so I just write it here. So it's gonna be right here. Okay, now the last one, this is the formula. Okay, so this is obvious, and then this is obvious too. Okay, all right, so I start solving the problem right now. Okay, so this guy right here, it should be integral from 0 to pi over 4. Okay, I keep s squared right here. Okay, now I just use the double angle formula right here. Sine 2s equal 2 sine s cosine s. Okay, now cosine. Okay, so the next one, cosine 2s equal cosine 2s right here equal 2 cosine of s minus 1, right? But because we have the negative sign in front of cosine 2s, right? So when we distribute -1 into this one, right, we will get minus what? 2 cosine square of s plus 1. Okay, over. Right, the bottom one right here, the formula right here. Okay, so we have sine s plus cosine s all together square times cosine square of s ds, right? Okay, now equal 0 pi over 4. Now I'm going to divide the top and bottom by cosine square of s. Okay, so what if I do this? I will get what? S square times this guy divided by cosine square of s, right? So I have 2 sine of s cosine of s divided by cosine square, right? Cosine square of s. So I only this guy gone. I only have cosine of s on the bottom, right? So I have 2 sine of s over cosine of s, right? And it's gonna be 2 tangent s, right? This is 2 tangent s, so I have 2 tangent s right here. Now the next one, negative 2 cosine square of s divided by cosine of s, it could be -2. 1 divided by cosine square of s, it could be 1 plus tangent square of s. Okay, so plus 1 plus tangent square of s. Okay, all right, so I can simplify this one too, right? Negative 1 plus 1 is going to be negative 1. So put negative 1 here, right? Okay, so this one I just rearrange them in the decrease in order. Okay, so I just rewrite this one. So I have tangent square of s plus 2 tangent s minus 1. Okay, right, over. Now the bottom one right here, I have what? Sine s plus cosine s all together square times cosine square of s, right? Cosine square of s. Alright, so when I divide by cosine square of s, so I just, because we need to divide by cosine square of s, right? So basically, I just combine this guy like this, right? Cosine, cosine s all together square outside. Okay, now sine s divided by cosine s is going to be tangent s, right? Cosine s divided by cosine s is going to be 1, so plus 1 square, right? So I write the answer over here. Tangent, I write cosine square of s right first. Okay, so cosine square of s times tangent square of s plus 1 ds. Okay, all right, so we're good to go, right? Okay, now I need to use the integral. Now I need to do the integration by part. Okay, so I let what? I let u equal s squared, and then we have du equal 2 ds. Sorry, 2s ds. 2s ds. All right, I have dv, right? dv equal this guy right here. Okay, this guy is dv, right? Equal that guy. Okay, that guy. Okay, so then I have v equal what? V equal this one, because we just take the derivative of this guy right here. So where's that? Oh, I forgot 2 right here, right? I forgot to put 2 right here. Okay, all right, so when I have dv of this one, okay, all right, so v should be this guy right here. Okay, so v equal tangent square of s plus 1 over, let me rewrite this one so make it better. Okay, so I have dv equal 2 tangent square of s plus 2 tangent s minus 1 over cosine square of s times tangent s plus 1 square. And then I have v equal what? V equal tangent square of s plus 1 equal tangent s plus 1. Okay, alright, so by integration by part, okay, we have the formula. It's gonna be, so integration by part is gonna be like this: uv, right, the evaluated from 0 to pi over 4 minus, alright, the integral from 0 to pi over 4, alright, v du. Okay, so v du, okay, so this is the formula. Okay, so uv, where's u equal s right? I use u equal s squared, v equal this one, so I have what? So basically equal s squared, right, times tangent square of s plus 1 over tangent s plus 1, right? Right, evaluated from 0 to pi over 4, okay? Pi over 4. Now minus the integral from 0 to pi over 4, right? V du, v is going to be like this, and du is going to be 2s, right? So I put 2 in the front, okay? Now I have s times tangent square s plus 1, right, over tangent s plus 1, right? I'm going to put 2 right here, so that's why I put 2 right here. So I don't need to put 2 here, okay? So I erase everything right here, so because I need more space, okay? Right, okay. So this is square, close parenthesis, and this is ds, okay? Now I need to calculate this one, okay? So I need to calculate this one. Pi over 4, substitute over here, it's going to be pi over 16, right? And tangent of pi over 4 is going to be 1. 1 square is going to be 1, right? 1 plus 1 is going to be 2. Bottom, 1 plus 1 is going to be 2. 2 divided by 2 is going to be 1. So, and then I have pi square equals pi square over 16. Now, the lower bound right here is 0. When you substitute 0 over here, everything is gone because 0 times this one should be 0, right? Okay, so this guy right here equal pi over 16, right? So this guy equal pi over 16. I write pi over 16, so I erase this one, okay? Alright, so it should be pi square over 16, okay? Now I need to calculate this one, okay? Now you see that one tangent square of s plus 1 right here. Let me erase this one so you can see it. Alright, tangent square of s plus 1 is going to be 1 over cosine square of s, okay? So basically this one I just rewrite. Alright, so pi square over 16 minus 8, okay? A equal this guy right here. Okay, so I need to calculate this guy. A equal this guy. So that guy equal what? So that guy equal, okay, integration by part. Okay, u equal 2s and v equal this one. So 2s times natural log of tangent s plus 1. Okay, evaluated from 0 to pi over 4. Okay, minus integral from 0 pi over 4. Okay, v du, v which means natural log of tangent s plus 1. And then du which means 2ds, so I put 2 right here, and then I put ds right here. Okay, now I erase everything. Okay, so basically this one I evaluated this one, so pi over 4 substitute here, so it should be 2 times pi over 4 times tangent of pi over 4 equal 1. 1 plus 1 equal 2, so it can be natural log of 2, right? Now 0 substitute over here, it's going to be 0, so the lower power should, when you evaluate this expression with the lower power right here 0, so it should be 0. Okay, so I simplify this one I simplify it turn out to be pi over 2 natural log of 2. Okay, all right, so I just write this guy equal pi over pi square over 16 minus parentheses pi over 2 natural log of 2. Okay, minus I. Okay, I equal what? I equal this guy right here. All right, so I write this. I don't need this anymore. Now I need to calculate this one. Okay. Okay, guys. So in order to calculate the integral from 0 to pi over 4 of 2 natural log of tangent s plus 1 ds, we have to use the king rule. Okay. King rule. So what does king rule say? If we have the integral from 0 to from a to b of f of s ds, and if we want to use the king rule, we just change the variable. Let's u equal a plus b minus s. Okay, so in this situation we have what? Let's u equal a equal 0, b equal pi over 4, so 0 plus pi over 4 equal pi over 4 minus s. Okay, and then we have s equal pi over 4 minus u. Okay, and we check the derivative both sides, so we have ds equal minus du. Okay, so we have ds minus du. Okay, now we change the variable, so I write over u equal pi over 4 minus s, and then ds equal du. Okay, all right, so it's gonna be equal integral from now s equals 0, u equal pi over 4, right? Zero, sorry, this is pi over 4, right? Pi over 4 to 0. Okay, now we have ds equal negative du, right? ds equal negative du. Alright, so I put the negative side right here, I put du right here. Okay, now 2 times natural log of tangent tangent of s equal pi over 4 minus u, right? So it could be pi over 4 minus u plus 1 close parenthesis du. Okay. All right. So I just flip the bounds right here. I flip the bounds right here. Okay. And then this side right here become positive. Okay. So basically it's gonna be 0 to I over 4 to natural log of tangent I over 4 minus u, okay, plus 1, all right, du, okay. All right, so now this formula right here, we need to apply this guy right here. All right, so we have, I put it on the side. Okay, so I have tangent of I over 4 minus u equal, all right, tangent of I over 4 minus tangent u over 1, okay, plus tangent pi over 4 tangent u, okay. Now I need to simplify this one. Tangent pi over 4 equal 1, so it should be 1 minus tangent u, okay, over this is tangent pi over 4 equal 1, so it should be 1 plus tangent u. Now I need to simplify with plus 1 right here, so I plus 1. So plus 1, I see denominator right here, 1 plus tangent u. So I can write this one as 1 plus tangent u over 1 plus tangent u, right? So this one go over here. So 1 plus tangent u over 1 plus tangent u. Now they have the same denominator. I just add the top, right? So I just add the top. So negative tangent u and tangent u gone. 1 plus 1 equals 2. So it could be 2 over 1 plus tangent u, right? Okay. Alright, so I keep that in my 2 over 1 plus tangent u, right? So I write this one. Alright, so it's gonna be equal 0 integral from 0 to pi over 4. Okay. Alright, so you have 2 right here. Alright, and this guy right here, alright, equal 2 over, natural log of 2 over 1 plus tangent u, okay, right, du, okay. So I keep applying the formula right here. Log a over b equal log a minus log b, okay. So equal integral from 0 to I over 4, alright, 2, alright, natural log of 2, alright, minus 2 natural log of 1 plus tangent u, right? And all together it should be du. Alright, so now I just break this integral down, right? Okay, so I need to erase the top right here. Oh, let me see. This guy right here, I know that this guy right here is gonna be I. So I got it right here. This guy right here is actually I, right? So I just write, right? So basically I just rewrite that this guy. Okay. So basically this one equal what? Integral from 0 to pi over 4 to natural log of 2, alright, minus, right, this one is gonna be I, minus I. Okay, so I have I right here equal this one. Okay, now I add I both sides, so I have 2I equal natural log of 0 to pi over 4, right? 2 right here, natural log of 2, right? Okay, so this one equal what? I divide both sides by 2, so I have I equal, right? Integral from 0 to pi over 4, natural log of 2, right? Okay, so, so I forgot this is du. Du or ds, it doesn't matter, right? It's just available. So I put this in du minus I, and this is du minus I. Oh, du. So then, all right. So I equal this one, right? So du. Okay. Now, so this is just a number, right? So it's gonna be equal what? Natural log of 2, right? Right? U integral from 0 to pi over 4. Okay. Alright, so this one I just write u in front of natural log of 2 so that you're not gonna confuse. So u natural log of 2 like this. Okay. Evaluate it from 0 to pi over 4, right? So have pi over 4 natural log of 2, right? U 0 substitute over here is gonna be 0. So finally this guy equal pi over 2 natural log of 2, right? Sorry, pi over 4 natural log of 2. Okay, now I bring it back over here. So I'm gonna end up with what? Okay, so this is my solution. Finally we got it. Okay. Oh, okay. So finally it's gonna be what? Equal pi square over 16, right? Minus parentheses pi over 2 natural log of 2 minus I, but I equal pi over 4. This is I, natural log of 2, right? Alright, so I need to simplify. So this guy right here, pi over 2, this is 4, so I need to write 2 pi over 4, right? Alright, so I just subtract 2 pi minus pi, it's gonna be pi. So the final answer should be pi square over 16 minus 2 pi minus pi is gonna be pi over 4 natural log of 2. And that's the answer, guys. Okay, so I hope you enjoyed the video. If you have another way to solve this problem, please leave a comment. Thank you for watching. See you next time. Bye bye.